Okay, so in this video, we are doing section 1.5, angles and angle measures. And the objective is, I know what an angle is and can use congruent angles to find missing measures. Now, I'm going to go through this lesson relatively quickly, just because if you need any extra time, the expectation is that you can pause the video to catch up. But you are going to want to make sure you get all of these notes down for 1.5. It's 3 pages, I know, but we will review this next time you see me. So first we're going to add a couple terms to our dictionary, which starts with ray. A ray is a part of a line that extends without end from one point. And a ray acts a lot like a sun's ray in that it starts from a single point and goes in one direction forever and ever. So this is an example of a ray. And we would refer to this as ray IJ. With line segments and lines, the order of the letters does not matter, but with rays, we always start with the end point. So if you notice, the ray starts at I, goes through J, and continues on forever. The ray notation works the same. So it starts with I, it goes through J. Also, ray notation always points to the right. It's always going to point to the right. So we could not name this JI. We could not name that JI because, again, the ray starts at I, goes through J, on forever and ever. And so we want that to match in the notation. The next term is opposite rays. So we're using ray again, but this is opposite rays. Those are two rays with a common endpoint. Two rays with a common endpoint. That makes a line. And so what happens with these is you have two rays that are coming from the same endpoint, but they literally go in a complete opposite direction of each other. That's why they're called opposite rays. So the common endpoint for both of these rays is L, and then I have ray LM and ray LK, and they're opposite rays. So it's two rays that are put together, like ray number 1, ray number 2, but when you put them together, they make a continuous line. So we could say, again, ray LK and ray LM, starting at the end point, going through the other point, are opposite rays. So now that we have some new vocab, let's answer some questions about a diagram. Example 1, use the diagram of the intersecting lines to answer the following question. So first, give another name for, and that's supposed to have a little ray symbol over it. Sorry, it's a typo. Give another name for ray EF. So what I want to do is identify ray EF. So here's EF, okay? So it's this ray right here, starting at E, going through F. I want a different way to name it. Well, we always start with the endpoint of a ray. So the only other way to name this would be to call it ray EJ. So again, if I had ray EF, but I had to name it another way, we still have to use the endpoint, but we could use any other point that is on that ray. So since J is on that ray, we can call that ray EJ. Then we want to name a pair of opposite rays. So there are actually two different options on this diagram. These are rays that have the same endpoint and go in opposite directions. So I can do those two rays, which would be ray, let's see, JG and ray JH. Or you could do the other two opposite rays, ray JF and ray JE. So a couple different options on those two. Then we're asked, are ray HJ and ray JH the same ray? Explain your reasoning. So ray HJ starts at H, goes through J, while ray JH starts at J and goes through H. So those are actually not the same ray, and it's because you cannot just change the letters when you are talking about notation for rays. So these are not the same ray, and the reason is they have different endpoints. And they point in different directions. They have different endpoints and they point in different directions. And so for a ray to be the same, it'd have to have the same endpoint and point in the same direction. And then lastly, it says name 3 different segments. Well, there are loads of segments on this picture, so you could pick any of those. Those are just line segments. So I'm going to do segment EJ, segment GJ, segment HJ, but again, there are many, many, and you can look at the key on Canvas if you want to see all of the different options. Now that we know what a ray is, that also lets us get some more new vocab, exciting, and we're going to be talking about angles. So an angle is a set of 2 rays, that share a common endpoint. Set of 2 rays that share a common endpoint. And so again, if we have a common endpoint, let's call it M, and I have one ray coming out of it that goes through A, and another ray coming out of it that goes through B, we have created an angle. So it's literally 2 rays that are coming out of a common endpoint. So if we want to practice our notation again, we could say ray MA, again, starts with M, goes through A. So ray MA and ray MB create an angle. Now we're going to talk about some vocab that's angle specific. So first we have vertex. That is what we call that common endpoint. So it's the common endpoint of an angle. The common endpoint of an angle. And so for our picture, I'm just going to actually refer to the picture above. It's the common endpoint. So M would be the vertex. And I can also write that for notation. Point M, capital M, because it's a point, is the vertex. Point M is the vertex. Now, naming angles is something we're going to practice a lot. It's very, very important, but we'll talk about it for a second. So the way you name angles typically is with 3 capital letters. Three capital letters with the vertex in the middle, super important. Or you can name it angle and then give a single letter or number if it's a solo angle. And so we'll talk about that in a second. Sorry, that's a bad middle. There we go. So 3 capital letters with a vertex in the middle, or you can call it angle blank with a single letter if it's just a single angle, and we'll talk about that more. So we can name this angle that we have above a couple different ways. I'm just going to take this whole section to write this out. So we can call it angle M. That would be an example. There's only one angle we are showing in that picture, so you can call it an angle and then a single letter or number. Or we could call it angle AMB. Again, the vertex has to be in the middle, so since M is the vertex, that would always be in the middle of those 3 letters. Or you could call it angle BMA. So those are your 3 options on naming that angle above. So for example number 2, that is what we are practicing. We are naming each angle at least 3 ways. So let's do the first 2 together, and then you can try that last one. So example A, I could call it angle G. Again, I can call it angle G because there's only one angle in the picture. I could call it angle EGF. The vertex has to be in the middle. Or I could call it angle FGE. Those are my 3 options on how to correctly name that angle. Example B, I can name it angle R, angle QRS, or angle SRQ. Again, the vertex has to be in the middle, so if I'm using the 3 letters to name it, that middle letter should be the vertex in every example. So go ahead and try to do example C on your own. Pause the video. All right, so for example C, there's actually 4 options. You could call it angle I, angle 3, just because that one has a 3 in it, so that'd be another option. Angle JIH, or angle HIJ. So now that we've done that, see if you can do the next 3 on your own. Let's practice what we've learned. So for example 1 and 2, I want you to name the vertex and sides of each angle. For example number 3, I want you to name each angle in 4 ways. So go ahead, pause the video, and try those 3 on your own. All right, so for this practice section, first off, number 1, the vertex is point D. That is the option. The sides are rays. Angles are made of rays, so I could call it ray DE and ray DC. It does have to be in that order for rays. The arrow needs to point to the right from the notation on both of those. Number 2, the vertex is point M. The sides are ray MN and ray ML. For number 3, you can name that 4 different ways: angle F, angle 1, angle EFG, angle GFE. Now that we've talked about what angles are, we are going to be doing some review from middle school just to kind of finish up this section on angles. So we're going to talk about different types of angles, and these are types of angles hopefully that you've seen before, but again, we're reviewing. So first off, acute angles. Acute angles are angles that are between 0 and 90 degrees. So here's how I'm going to write this. 0 degrees is less than an angle measure, and the angle measure is less than 90 degrees. So if the angle measure is between 0 and 90, we would call that an acute angle. And acute angles are smaller than 90-degree angles, and they typically look like an A. So if I turned that angle on its side, it looks like a capital A, which is one of the easiest ways to remember what an acute angle is. Now that's different than right angles. So for a right angle, your angle measure would be equal to 90 degrees. It's exactly 90 degrees. And these are the angles that have a little box in the corner. They have a little box in the corner. So these are angles you've probably seen for a couple years now, at least. And they get that little box. That just means it is a right angle. It is a 90-degree angle. I am going ahead and putting a vertex on all of these as well, just to make the pictures better. Obtuse angles are between 90 degrees and 120 degrees. Sorry, 180 degrees. I'm trying to write and talk at the same time. There we go. So obtuse angles are between 90 degrees and 180 degrees. These are those really wide angles. So again, they have a vertex, they have 2 rays with a common endpoint, and they're just wider. So it's larger than a 90-degree angle, but smaller than what we call a straight angle. A straight angle is the last type of angle we're going to talk about, and they have an angle measure that's exactly 180 degrees. So when we talk about opposite rays are always making a straight angle because they're opposite, they go completely in opposite directions, and they make up that straight line, which is 180 degrees. So again, I know I'm moving fast, but if you need to pause the video, please do that to catch up on vocab. So So we're on the last page. It says find the angle measure, then classify the angle. So first I want to find angle JHM. So let's look at our diagram. Again, based on how it is named, we can figure out that angle. So JHM goes from J to H to M. So it's going to be this angle. And this is a protractor that we can use to measure. So as I look from this, I want to measure from the side that has 0. So if you look, J is on the side where 0 is inside the protractor. So what I'm going to do is we're basically counting. It's going to be 0, 10, 20, 30. We're going all the way around to see what the measurement of that angle is. So if we're using those inside numbers, it looks to me like that angle is somewhere between 140 and 150. 140 and 150. So I think it's 145 degrees, which would make it obtuse. Next, I want angle GHL. GHL, so here's G to H, and then H to L. That is a 90-degree angle. And again, we are counting the number of degrees. So for this angle, you can either use the outside numbers or the inside numbers to get that it is a 90-degree angle. Lastly, I want the measure of LHK. So that one's a little bit trickier, LHK. We can do this a variety of ways. We can either find this larger angle and then subtract the smaller angle from it, or we can count between those two numbers. So it looks like ray HL starts at 90, and it goes 10 degrees, 20 degrees, 30 degrees, 35 degrees. So I believe that is a 35-degree angle, which would be acute. So again, kind of tricky, but protractors are something that we see in middle school. We don't see them a ton in high school, but they're around. They're around. We use them for angle measures. Then the last thing that we're going to be talking about today is congruent angles. So congruent angles are angles I guess this is just a statement. Angles are congruent when they have the same angle measure. Angles are congruent when they have the same angle measure. And so say I gave you two angles, this one that was, let's call it 40 degrees, and I can call it angle X. And then I can have another one that's 40 degrees. I can call it angle Y. I can say that the measure of angle X is equal to the measure of angle Y, or that angle X is congruent to angle Y. If you're talking about the measures, you use an equal sign. If you're talking about congruence, you don't use the measure, the little M, to tell you that it's a measure. Then I can do example number 4. In the image of a protractor above, name a pair of congruent angles. Now there are a couple different congruent angles that would work, but I prefer to do the easy ones. So I'm going to do the two right angles. So I can say the measure of angle GHL equals 90 degrees. That's this right side, or sorry, the left side right angle. And then I can say, okay, also the measure of angle JHL is equal to 90 degrees. So angle GHL is congruent to angle JHL because they have that same angle measurement. They're both right angles. All right angles are congruent to each other. And last but not least, we're not going to get away without doing some equations. So example 5, in the following, angle TVS is congruent to angle SVR. Let's go ahead and write out that they're congruent using our little arcs. That shows that we have congruent angles. And let me put 2 on each so that that's obvious. So what we're going to do is we're going to set the angles equal to each other. If I set the angles equal and they're congruent, I can solve that equation for my missing variable, and then I also can find the measure of each angle. So I have 15x minus 10 equals 3x plus 38. Now if you want to pause the video, you can go ahead and solve this and see what x value you get. So the first thing I'm going to do is subtract 3x from both sides. I get that 12x minus 10 equals 38. I can then add 10 to both sides to get that 12x equals 48. And I can divide both sides by 12 to get that x equals 4. So that is the variable I was looking for. Additionally, though, I was told to find each angle measure. So I can do that by plugging in my x value. 3 times 4 plus 38 is 12 plus 38, so 50 degrees. Then I can do the same thing here. 15 times 4 minus 10, which would give me 60 minus 10, or another 50 degrees. And again, I knew that those were congruent, so that tells me I got the right x value because they ended up being the same angle measure. And then last but not least, example 6. Again, we are told to use the diagram. We are just solving for x in this. And then if you look, it's a little tricky, but they do give you those arcs to tell you, hey, those are congruent. So once again, we're going to set the angles equal to each other and solve. So 5x plus 7 equals 3x plus 23. I'm going to subtract 3x from both sides. I get that 2x plus 7 equals 23. I can then subtract 7 from both sides to get that 2x equals 16, and divide both sides by 2 to get that x equals 8, which is the final answer on that one. So again, I know I went through this fast, but hopefully you paused as much as you needed to get caught up on that. You're also welcome to rewatch this video. After this, you are working on your homework options. So go see what your options are for 1.5. Get those done before you work quietly on other stuff.